Hi everyone, this is Glenda Ganzon and welcome to my Human Anatomy and Physiology class. And for today's lesson, I'm going to give you the importance and function of water in the human life. An adult's body weight contains as much as 70% of water, and this water is contained both within the cells and between the cells that make up the tissues and organs. Its several roles make water indispensable to human functioning. So the first function of water is it serves as a lubricant and cushion. Water is the major component of many of the body's lubricating fluids. Just as oil lubricates the hinge on a door, water in synovial fluid lubricates the actions of body, joints, and water in pleural fluid helps the lungs expand and recoil with breathing. So watery fluid helps keep food flowing through the digestive tract and ensure that the movement of adjacent abdominal organs is friction-free. Water also protects cells and organs from physical trauma, cushioning the brain within the skull, and protecting the delicate nerve tissues of the eyes. Water cushions a developing fetus in the mother's womb as well. Another function of water is it is used as a heat sink. So what is a heat sink? A heat sink is a substance or object that absorbs and dissipates heat but does not experience a corresponding increase in temperature. So in the body, water absorbs the heat generated by chemical reaction without greatly increasing the temperature. Moreover, when the environmental temperature soars, the water stored in the body helps keep the body cool. So this cooling effect happens as warm blood from the body's core flows to the blood vessels just under the skin and it is transferred to the environment. So at the same time, sweat glands release warm water in sweat. So as the water evaporates into the air, it carries away heat and then the cooler blood from the periphery circulates back to the body core. The third function of water is it is used as a component of liquid mixtures. A mixture is a combination of two or more substances and each of which maintains its own chemical identity. So in other words, the constituent substances are not chemically bonded into any larger chemical compound. So the concept is easy to imagine. If you think of powdery substances such as a flour and sugar, when you stir them together in a bowl, they obviously do not bond to form a new compound. So the room air you breathe is gaseous mixture containing three discrete elements such as nitrogen, oxygen, and argon. So one compound which is carbon dioxide. And there are three types of liquid mixtures and all of which contain water as the key component. These are solutions, colloid, and suspensions. In order for the cells in the body to survive, they must kept moist in a water-based liquid called solution. In chemistry, a liquid solution consists of a solvent that dissolves a substance called a solute. An important characteristic of solution is that they are homogeneous, which is the solute molecules are distributed evenly throughout the solution. So if you were to stir a teaspoon of sugar into a glass of water, the sugar would dissolve into sugar molecules separated by water molecules. And the ratio of sugar to water in the left side of the glass would be the same as the ratio of sugar to the water in the right side of the glass. And if you were to add more sugar, the ratio of sugar to the water would change, but the distribution, provided you had stirred well, would still be even. That's why water is considered as the universal solvent, and it is believed that life cannot exist without water because of this. Water is certainly the most abundant solvent in the body. Essentially, all the body's chemical reactions occur among compounds dissolved in water. Because water molecules are polar with regions of positive and negative electrical charge, water readily dissolves ionic compounds and polar covalent compounds. Such compounds are referred to as the hydrophilic or water-loving. As I've mentioned earlier, sugar dissolves well in water. This is because sugar molecules contain regions of hydrogen-oxygen polar bonds, making it hydrophilic. Non-polar molecules which do not readily dissolve in water are called hydrophobic or water-fearing. Another function of water is concentration of solutes. Various mixtures of solutes and water are described in chemistry. So the concentration of a given solute is the number of particles that solute in a given space. For example, oxygen makes up about 21% of atmospheric air. So in the bloodstream of humans, glucose concentration is usually measured in milligrams per deciliter, and in healthy adult averages about 100 milligrams deciliter. So another method of measuring the concentration of solute is by its molarity, which is moles or of the molecules per liter. So the mole of an element is its atomic weight, while the mole of a compound is the sum of the atomic weights of its components, and it is called the molecular weight. And often used, for example, is calculating a mole of glucose with the chemical formula. Using periodic table of elements, the atomic weight of carbon, for example, is 12.011 grams, and there are 6 carbons in glucose, for a total atomic weight of 72.066 grams. Doing the same calculations for hydrogen and oxygen, the molecular weight is equal to 180.156 grams, the gram molecular weight of glucose. So when a water is added to make 1 liter of solution, you have 1 mole of glucose. And this is particularly useful in chemistry because of the relationship of moles to Avogadro's number. A mole of any solution has the same number of particles in it. And many substances in the bloodstream and other tissue of the body are measured in thousands of moles or even millimoles. So what is a colloid? A colloid is a mixture that's somewhat like a heavy solution. The solute particles consist of tiny clumps of molecules large enough to make the liquid mixture opaque. Because the particles are large enough to scatter light, familiar examples of colloids are milk and cream. For example, in the thyroid glands, the thyroid hormone is stored as thick protein mixture, also called a colloid. On the other hand, suspension is a liquid mixture in which a heavier substance is suspended temporarily in a liquid but over time settles out. This separation of particles from the suspension is called sedimentation. An example of sedimentation occurs in the blood tests that establish sedimentation rate or SED rate. The test measures how quickly red blood cells in a test tube settle out of a watery portion of blood. This is known as plasma over a set period of time. Rapid sedimentation of blood cells does not normally happen in the healthy body, but aspects of certain diseases can cause blood cells to clump together, and these heavy clumps of blood cells can settle to the bottom of the test tube more quickly than do normal blood cells. So this ends my lecture about the functions and importance of water in the human life. Should you have any question, please write it in the comment section down below, and I'll be glad to answer them all. And once again, thank you so much for watching this video and for listening to my lecture. Until my next video, bye!